बिस्मिल्लाहिर्रहमानिर्रहीम। अच्छा बेटा, हम लोग जो थे वो स्टेटिस्टिक्स में कॉम्बिनेशन ऑफ वेरिएबल्स पढ़ रहे थे, और कॉम्बिनेशन ऑफ वेरिएबल्स पढ़ते हुए हमने ये चीज जो थी पढ़ी थी पिछले लेक्चर में कि y अगर ax प्लस b के बराबर है, इफ y इज इक्वल टू x प्लस b, देन एक्सपेक्टेड वैल्यू ऑफ y इज a टाइम्स एक्सपेक्टेड वैल्यू ऑफ x प्लस b, whereas the variance of y is just a square times the variance of x. That means that this b carries no significance. This was the, in case of variance, this was the first result that we proved in previous lecture. Then, we went through all of this proofs, and we finally established a result that if a is equal to x plus y, then expected value of a is expected value of x plus expected value of y. And then we proved that variance of a is equal to variance of x plus variance of y. Then, going through this all business, we were able to establish this proof that if y is x1 minus x2, expected value of y is equal to the expected value of x minus expected value of x2, but variance of y was equal to variance of x1 plus variance of x2. Even though that the y is connected to x1 and x2 with the help of this negative sign, but when we are calculating the variance of y, we put a plus sign over here. We proved it mathematically. We over here, when we use this example in which we showed that x itself was ranging from only 1 to 6, but the difference was ranging from minus 5 to 5. The variance of y clearly was more than the variance of x, and it was due to this reason that we arrived at this conclusion. Then we studied the sampling distribution of x1 plus x2 and only the twice of x1. We proved over here that the variance of C is equal to variance of x1 plus variance of x2. But in the case of D, variance of D is 4 times the variance of x1. So combining all this knowledge, now if you say if y is equal to x1, x2 minus x3, where x1, x2, x3 are the observations of some same variable, and plus 2 times the value of u plus 3 times the value of w minus 4 times the value of p plus 1000, we know that the expected value of y bears the same relationship with the expected value of the x u w p. And when we calculate variance, this negative sign is converted to plus, this 2 is squared, it becomes 4 over here, this 3 becomes 9 over here, and this minus 4 becomes plus 16, and this 1000 carries no significance in the case of variance. Okay, so then we did some research over here. Now our today's lecture will just be only connected to only this simple fact that if x is a variable which is normally distributed with some average and some variance, and y is some other variable which is also normally distributed with some average and variance, then a linear combination of x and y, that means some number multiplied to x plus some number multiplied to y, when combined, is also normally distributed with some average and variance, and the average and the variance of this thing can be calculated using our knowledge of combination of variables. Okay, now we will study the application of this. We'll do 5 questions of this. Okay, we'll do only 5 questions of this, in which we will study the combination of variables. Okay, application of the combination of variables. This paper is 9702, 73 October, November 2017. It is the question number 6 of the paper. And it's my question 1 for this lecture is this question. The number of barrels of the oil in millions extracted per day in 2 oil fields A and B are modeled by an independent random variables x and y respectively, where x is normally distributed 3.2 million barrels from the oil field A. Okay, and 3.2 million barrel is the average extraction. Sometimes you extract more than 3.2 and sometimes you extract less than 3.2. Okay. Similarly, from the oil field number B, you daily extract 4.3 million, as it is stated over here, barrels of the oil. Okay. With this variance, this zero point 0.4 square and 0.6 square are the variance. The income generated by the oil from two field is $90 per barrel from A and $95 per barrel from B. The reason that this price is higher for the B is that the oil of the B must have been of better quality. It is due to this reason that, or the extraction from the oil field B is difficult. These are the two reasons for which the price of the oil from B might be more. Okay. Now the question part one is find the mean and the variance of the daily income in millions of dollars generated by field A. Okay. Now field A produces 3.2 million barrels and we charge $90 per barrel. Okay. You just simply multiply 90 by 3.2 million and you get this much $1 million from the oil A. So $288 million is the average mean daily income generated by the field A. And you can say, you know, that income over here, I will call it as income 1, IA, is 90x. So when you are calculating the variance of I income from oil field A, you just square this 90 square, because you know from your knowledge, you studied this thing, that if y is related to x like this, y is equal to ax, you can assume b is 0, then variance of y is a square times the variance of x. So we are going to use this thing over here. So the variance is 90 square times the variance of x. Variance of x was 0.4 square and we put it over here, and this becomes equal to 36 square. Question part 2, find the probability that the total income produced by the two fields in a day is at least $670 million. Okay. Now, if I write an expression for the daily income, combined income from the two oil fields, I would say that X is the production of oil from oil field A multiplied by the $90 plus Y is the production of the oil field B multiplied by $95, because we've been told that it's $90 per barrel for A and $95 per barrel for B. So this is an expression for the income. Okay, now expected value of the income is 90 times the expected value of X plus 95 times the expected value of Y. Expected value of X is $3.2 million, a million barrels. And expected value of Y is 4.3 million barrels. So this thing amounts to $696.5 million. Okay, this thing amounts to $696.5 million. This is the average income, combined income from the two oil rigs. Okay, now income is equal to 90x plus 95y, the variance of I income, the scatterness found in the income, the variety found in the income is equal to 90 square, the variance of x, plus 95 square, variance of y. And if you can't understand this thing, just go back and again you recall this thing. When it was 2x, it was 4 over here, and then we studied over here. Then you know that all the coefficients will be squared. All the coefficients over here will be squared. You know, 2 will become 4, 3 will become 9 over here, and minus 4 will become 16 over here. The coefficients become squared, okay? In the case of variance, not in every other case, in the case of variance. So the income is equal to 90 square variance of x, which is, you know, 0.4 square, plus 95 square variance of y, which is 0.6 square. This thing when calculated becomes equal to 45 or 67.42 square. Now the income is normally distributed with $696.5 million and with this much variance. And they are asking find the probability that income on one day exceeds $670 million. We know we can use normal distribution. We will replace income by Z, and then applying this formula, we know the famous formula of Z, X minus average over standard deviation. Using this converting formula, we calculate the corresponding Z, and we know that when we say Z greater than minus 3.393, minus 0.393 will come over here, and this green area is the answer of this inequality. And you know that this green area by symmetry is equal to this. So hence we'll say phi of 0.393, area behind 0.393, and from table it comes out to be 0.6528. So this is the first question in which you have assumed that if x and y are normal, then ax plus by is also normal. And you have used the knowledge of combination of variables. Now, my question 2, 970973 May, June 2014, statistics question number 8 of the paper. Okay, they say, I haven't written the whole theory of the question over here. They say that a student gives theory paper, and in theory paper, their marks of the students have an average of 57 with variance of 13. And the practical paper in which they appear, the practical paper also has a normal distribution with an average marks of 28 with the variance of 5. They haven't given us the total marks, 57 out of how much and 28 how much, we do not know. And the final score is calculated by adding the theory paper and by multiplying the practical paper's marks by 2.5 and then adding it to theory paper. This is the final score. It is the information given in the paper. It was written in the paper that total final score is calculated in this way, that practical marks are multiplied by 2.5 and then added to the theory, and in this way final score is calculated. I represent final score by Fs, which is equal to the marks in theory paper plus 2.5 times the marks in practical paper. Now the expected value of final score is equal to expected value of x plus 2.5 times expected value of y. Expected value of x is 57 average, and expected value of y is 28, and you know this is the total average score 127 of any student appearing in this exam. Then variance of final score is equal to the variance of x plus 2.5 square. 2.5 square, this 2 refers to the square of 2.5 times the variance of y. The variance of x is 13, and 2.5 square is equal to 6.25, and the variance of y is 5. This makes total variance of score in the final score in the paper is 44.25. Now I can write it like this, that final score is normally distributed with an average of 127 and variance of 44.25. The question is, find the probability that this candidate has a final score that is greater than 140. Okay, probability that final score is greater than 140, converting it into Z, 140 minus the average over divided by the standard deviation. I do not know the value of standard deviation, but if I square root the variance, I'll get the standard deviation. It turns out to be that probability is equal to Z greater than 1.954, which is equal to this area if we draw it on the normal distribution curve, which is equal to 1 minus phi of 1.94. Phi of 1.954 is the area behind this value of Z. And I look up this value from the table, and then when I subtract it from 1, I get this answer. It was written in the question that do not apply any continuity correction, you know, because the marks are basically discrete. And if you want to convert them into continuous, you apply continuity correction. Okay. Now the second part of the question says that a candidate is chosen at random. Find the probability that this candidate obtains at least 20 more marks in the theory paper than in practical paper. Okay. Now I define another variable, more marks. I subtract the practical marks from the theory marks. Okay. X is the marks in theory and Y is the marks in practical. Expected value of more marks is expected value of marks in theory minus expected marks in practical. It turns out to be 28, and the variance of this is variance of X plus variance of y, you know that this minus will get converted into plus when we are calculating the variance. It is equal to 13 plus 5. From where I obtained the value of 13? From here and here. 13 plus 5. I get this value, which is equal to 18. Now the extra marks, the more marks of theory from practical varies normally follows a normal distribution with an average of 29. That means on average students score 29 more marks in theory than practical with a variance of 18. So he is asking the probability of 20 more marks. So probability of applying 20 more marks, that more marks should be more than 20, and z more than 20 minus 29 over under root 18. Probability z greater than minus 2.12. Probability z greater than minus 2.1. And when you draw the normal distribution curve, it's minus 2.12 over here. And by symmetry, it is equal to this black area, which is also phi of equal to phi of 2.12. And then you just simply put phi of 2.12 over here, because this thing is equal to this thing, and then you can use the table to calculate this value. From in this way, you will be able to calculate the probability. Okay. Now my question 3, and I do not know the year of this question, but it is from some modern paper. Okay. Each box of fruity flakes contains X grams of flakes and Y gram of fruit, where X and Y are independent random variables having distribution of this, that flakes are normally distributed with 400 flakes, and the actual amount of fruit is 100 with 20, okay, respectively. The weight of each box when empty is exactly 20 grams, okay. So the box itself is of 20 grams, and since it is exactly 20, that means you can't assume that the weight of the box is also random or it's taking some values. So you will just assume its value 20, okay. A full box of fruity flakes is chosen at random. Find the probability that the total weight of the box and its contents is less than 530 grams. Now we make that, we define another variable which is called total variable, total weight. Total weight is equal to the weight of the in grams of the flakes, and y is the weight in grams of fruit, plus 20 exact weight of the box. There is no variation in the weight of box. It is assumed that boxes are made very precisely and they do not show any variation, okay. Expected value of the total weight is equal to expected value of x plus expected value of y plus 20. And you know that expected value of x is 400 and expected value of y is 100. This total becomes equal to 520 gram. Now the variance of t is equal to variance of x plus variance of y. You know that the constant has no significance in the case of variance. You know from the first rule that you studied over here that if y is equal to ax plus b, then in expectation you do put b over here. But when you are calculating variance of y, it's a square variance of x. If you want to remember that why we do not add constant in calculating variance, I gave you an example that if there are 3 brothers having ages 3, 4, 5, their standard deviation is equal to 0.67. And after 10 years, those 3 brothers will have ages 13, 14, and 15. Still their standard deviation is equal to 0.67. That means addition of a number doesn't change their relative scatterness, okay. Now we move on to the the second part of this question. It says find the probability that the weight of flakes in the box is more than 4.1 times the weight of the fruit in the box. Somebody is, more lover of lover of flakes than fruit, so he is interested in a box which contains much more flakes than the usual extra flakes. So he is interested in that instead of flakes being 4 times the weight of fruit, they should be 4.1 times more, even more than that. Okay, we define another variable difference, weight of the flakes minus 4.1 times the weight of the fruit. We define this variable like this, and if the weight of the flakes is bigger than 4 point, if the we want to calculate the probability that the weight of the flakes is bigger than the 4.1 times the weight of the fruit. This is what we want to calculate. You can bring this 4.1y over here and it becomes x minus 4.1y greater than d. And you have defined this equal to d. So you actually want to calculate probability of d bigger than 0. So for this, you need to have the average and variance of the d, which you can calculate by using your knowledge of combination of variables. You know that the expected value of d is equal to expected value of x minus 4.1 times expected value of y. The expected value of x was 400. You can see over here, it was 400, and the value of y was 100. So inserting these two values, we get 400 minus 410 minus 10. Okay, now the variance of d, you know, variance of x plus 4.1 square times the variance of y. This negative sign will be converted to plus. We proved it mathematically. And if you still again want to have a look on the proof, it was here. It was on this sheet where we calculated x1 minus x2, and the y was starting from minus 5 to plus 5, clearly indicating that y was carrying more variation than x individually and y x2 individually. It is due to this reason that the scatterness of y was the sum of the scatterness of the x1 plus x2, was the sum of the scatterness of x1 and x2. Okay, now going back to the same thing, 4.1 square into 20 and 50. We calculate these values of 20 and 50 from here and from here, okay. Now this is the variance in this difference d. D is normally distributed with this average and with variance of 386.2. We want to calculate the probability that we may hunt up a box which contains flakes which are more than 4.1 times the weight of the fruit, which is equal to x minus 4.1 y being bigger than 0, d greater than 0, and then you know z is equal to x minus mu over standard deviation. Z is bigger than 0.51, which is equal to this shaded region, and 1 minus phi of this. And you know, if you look from the table for z is equal to 0.51, this is the value that you will read from the table. And you know that when you are looking for the values, you will see from 0.5 and 0.1 where you will look at this value. Okay, you will be able to find this value at the very top left corner of the table. Okay, and then when you subtract it from 1 minus 0.695, you get this value. Now in the second last question, this is the combination of variables of Poisson distribution. It is not the combination of variable of normal distribution. Okay, men arrive at a clinic independently at a rate at random at a constant mean rate of 0.2 per minute. Okay, women arrive at the same clinic independently and at random at a constant mean rate of 0.3 per minute. Okay, find the probability that at least 2 men and at least 3 women arrive at the clinic during a 5-minute period. You know that the arrival of the men is is shown like this for 1 minute for 5 minutes. Okay, this is the average rate at which the men arrive in the clinic in 5-minute period. If they arrive at a rate of 0.2 per minute, 0.2 multiplied by 5 is the number of men arriving at a constant rate in the 5-minute period, and I've shown it over here. And for ladies are arriving at 0.3 per minute, so 0.3 into 5 is the number of ladies which are arriving at a constant mean rate per 5-minute period. The reason that I am talking about 5-minute period is that they are talking about they want us to calculate the probability of 5-minute period. Find the probability that at least 2 men and at least 2 women arrive at the clinic during a 5-minute period. No, we can't do this question like the questions of the normal distribution. We will have to use a separate probability and then probability that the number of people, number of men being more than two, and the probability that number of ladies being more than three, or at least three. We have to calculate their individual probabilities and then we will multiply them because they are connected by and. And x greater or equal to 2, 1 minus probability x less than or equal to 1. And for ladies, 1 minus probability y less than or equal to 2. And then the famous formula of Poisson distribution, which is equal to what? E minus lambda, lambda raised to power r over r factorial. Using that formula, I've calculated the probability of 0 men and 1 man, and probability of 0 women, 1 woman, and 2 women, and I added them all, and then I subtracted them from 1. And in this way, I will calculate all this probability. Okay. Okay, then he is combining these two. Find the probability. No, over here he is actually calculating the total number of ladies and men. Find the probability that fewer than 36 people arrive at a clinic during a 1 hour period. Over here he hasn't said so many men and so many women. Okay, now here we are going to add both of them. So 0.2 men per minute and 0.3 women per minute, a total of 0.5 people per minute arriving on the clinic. Okay, so if x is the number of men coming and y is the number of women coming, I add them simply and it comes out to be 0.5 per minute. Now x plus y per minute, if it is 0.5 per minute, then they are 30 per 60 minutes, because I will multiply it with 60 and I'll multiply this 1 minute as also with 60. I get there on average a total of 30 people arrive per 60 minute, or per 60 minute is 1 hour. So that means in that clinic a total of 30 people arrive per 1 hour. Okay. Now in case of Poisson, you know that the average and variance are same. So 30 is the average and 30 is the variance as well. So he says, what is the find the probability that fewer than 36 people arrive at a clinic during a 1 hour period. Okay. So since I am applying a normal distribution and Poisson distribution is discrete, and I am moving from discrete to normal, I will apply continuity correction. And over here 36 becomes to 35.5, and then z, converting it from z and declaring it x minus mu over standard deviation. Probability z less than 1.005. It is equal to phi of 1.005 indicated by this shaded region, and from table it comes equal to it is read from the table, it becomes equal to 0.8422. Last but not least, okay, I haven't written the whole question over here, I've just written the essential details. Weights in kgs of men and women have a distribution. The average weight of men is 78 kg with this much variance, and the average weight of the ladies is 66 kg with this much variance. The maximum load that a certain cable car can carry safely is 1200 kg. If RC means randomly chosen. If 9 randomly chosen men and 7 randomly chosen women enter the cable car, find the probability that cable car can operate safely. Now the total weight of the people is first men 1 plus men 2 plus men 3 plus men 9 plus women 1 plus women 2 plus women 3 up till women 7. Now expected value of the total weight is 9 times of these expectation of M, because all men have an average mass equal, and 7 times the average mass of the lady woman. 9 times the expectation of men plus 7 times the expectation of women, and it is 9 into 78 from here, and 7 into 66, it is equal to 1164. Then I calculate the variance. The variance will be over here. The point that I want to mention, and the point I have included this particular exercise, is that it's not the weight of one man multiplied by 9. Had it been weight of one man multiplied by 9 and weight of one woman multiplied by 7, we would have calculated the variance like this: 81 times the variance of men and 49 times the variance of women. But this is not the case over here. these are 9 different men, okay? So variance of M1 plus variance M2, M2 plus variance of M3 plus variance of M9, this makes it to 9 times the variance of X. This is the difference. If the question was like this, that we choose only one man and then multiply the weight of that man by 9 and then calculate our charges or whatever, anything related to 9 times the mass or weight of one man, only in that case you would have done this 81 variance. If they say that we just only choose one man and we choose only one woman and we multiply the weight of the man by 9 and the weight of the woman by 7, and then in this way we calculate some tax or whatever, anything, and only that case, if you are calculating the variance of t, you will do 9 square or 7 square. But in this case over here, it is due to this reason that I've included this fifth question, that I wanted to make sure that you should know that these are 9 different observations of variable m. This is not one observation of m multiplied by 9, okay? Now these are 7 different observations of the variable w. If you remember it from this particular example that I quoted over here, it was one observation of u which was being multiplied by 2. And it is due to this reason that it became 4 over here. And it was one value of some w which was multiplied by 3. So therefore this 3 became 9 over here. And it was one observation of p, which one squared became 16 over here. But these are 3 different observations of x1 of the same variable. When they are calculated like this, you will calculate the variance of x1 plus variance of x2. You will convert this negative to positive in the variance of x3. And then you will add them up, making them 3 times the variance of x, because they are 3 different observations of the same variable. So you will not make it 9. That's very important. And that is the last important point that you need to know in this topic of combination of variables, okay? Now, the variance of t becomes equal to 9 times 7 square, and then 7 times 5 square, 616. So the total weight in a lift with 9 people and 7 women on 9 men and 7 women on board is 1164 kg with 616 kg square variance. Now they say that the lift can operate safely as long as the total weight stays less than 1200 kg. The probability that the total weight stays less than 1200 is equal to z less than 1200 minus 11. I haven't done applied continuity correction over here because weight itself is a continuous variable. I'm not moving from discrete to continuous. So 1200 minus the average over under root of the variance. This is equal to probability z less than 1.45. And you know, this is equal to this red area and phi of 1.45, and from table it's 0.9427. Okay. Find the probability that a randomly chosen woman weighs more than a randomly chosen man. Okay. Okay. Over here, he wants you to calculate the probability that a randomly chosen woman weighs more than a randomly chosen man. This probability will be it will not be very negligible. There are ladies which weigh more than men. So difference is equal to men minus women. Okay. Expected value of difference is 12. Men's are generally 12 kg heavier than ladies, and their variance is equal to, again, the negative is converted to plus 7 square plus 5 square, 74. If woman weighs more than men, then D is negative, because if woman weighs more than men, then this will be more than M, then D will become negative. So we are actually calculating the probability that D is less than 0, because men less than women, men minus women less than 0, and men minus women is difference. Probability that difference is less than 0. Z less than 0 minus average over under root of variance. It is probability Z less than minus 1.395, which is equal to this red area. And you know, by symmetry, this red area is equal to this, because the table does not contain the negative Z's. So we have to use the value of, we have to use the property of symmetry. And when we use it, this is our answer. This brings this chapter to an end. And this chapter is given in big detail in the chapter 18:8 of the Krasha, and in I think in statistics too. You can see, you can find this these questions of this type in the chapter 2. Okay, so Allah Hafiz, Assalamu Alaikum.